Imagine a tutor who never tires, never forgets a mistake you made last week, and always knows the single next activity that will make learning click. That's what modern AI virtual tutors aim to be. Personalized coaches that adapt the pace, select practice, and scaffold explanations for each learner's unique edge. These systems are not magic. They're engineered combinations of diagnostic assessment, knowledge mapping, spaced retrieval, and pedagogical heuristics, all driven by models that observe how students think, not just whether they get answers right. Adaptive teaching, customizing pace and practice. How adaptive teaching works in plain language. At the center is a knowledge model, a network of micro skills and dependencies that maps what students must know and in what order. When a student interacts with a virtual tutor, each response updates a belief state, a probabilistic estimate of mastery for each micro skill. The tutor uses that belief to choose the next content, a remedial worked example, a conceptual question, a practice set with varied contexts, or a challenge problem. The decision is driven by three priorities: efficiency, learn the skill with minimal practice; durability, ensure the learning sticks; and transfer, apply the skill in new contexts. Pacing is personalized. Fast learners get more complex problems sooner. Learners who hesitate receive more scaffolded steps and explanatory feedback. The tutor modulates exposure frequency using spaced repetition principles. When confidence is low, review comes quickly. When confidence is high, intervals widen to conserve time. This avoids the twin traps of boredom and overwhelm. Practice selection is not random, it's evidence-driven. The system chooses problems to maximize learning gains per minute. It balances worked examples for novices, guided practice for building fluency, and interleaved retrieval to strengthen transfer. Research in cognitive science shows that interleaving and desirable difficulties boost long-term retention. Modern tutors implement these ideas algorithmically. Rather than give 10 similar drills, the tutor mixes related problem types to force students to retrieve the underlying concept rather than memorize surface patterns. Explainability and pedagogical transparency matter. The tutor must explain why it assigns a task. We're practicing proportion problems because your last 3 ratio questions showed substitution errors. This transparency increases student buy-in and helps teachers understand the logic. Good systems produce a short, human-readable rationale for each decision and provide the student with a tiny roadmap. Today's goal: confident 2-step ratios, which focuses attention. Adaptive explanations change with the learner. For example, a student who repeatedly confuses slope and intercept will receive explanations that compare the two using concrete representations, graphs, tables, motion metaphors rather than abstract algebra. The tutor can use multiple representations, symbolic, graphical, narrative, because research shows that learners build stronger mental models when concepts are seen in varied forms. The role of prior knowledge and misconceptions. Great tutors don't treat errors as binary. They probe for why an error happened. If a student misapplies the distributive property, the tutor may run a short diagnostic. Show me how you'd expand 3 times x plus 2. Based on the step pattern the student uses, the tutor chooses either a conceptual mini-lesson or targeted practice. This error diagnosis is essential. Intervening at the wrong level, giving advanced problems to someone with a fragile foundation, wastes time and damages confidence. Scaffolding and fading are built in. At the start of learning a new skill, the tutor provides worked examples, step-by-step hints, and explainers. As accuracy and speed improve, support fades. Hints vanish. Problems require more independent steps, and the tutor asks for student-generated explanations. This mirrors proven instructional design. Scaffold early. Remove support as competence grows. Equity by design. Adaptive systems can reduce opportunity gaps by giving students precisely the extra practice they need. But equity requires careful calibration. The knowledge model must include culturally diverse examples and avoid biased priors that assume certain backgrounds. The tutor should offer multiple contexts for practice, urban versus rural scenarios, different cultural references, and allow language supports so English learners can access the same concepts. Monitoring for fairness, who gets extra challenges versus extra support, must be baked into deployment metrics. Human in the loop and teacher empowerment. Virtual tutors don't replace teachers, they augment them. Teachers get actionable dashboards, which students are stuck on which micro skill, suggested small group activities, and prompts for targeted whole class mini lessons. The tutor can run the initial diagnostic and free teachers to do what humans do best: lead discussions, interpret nuance, and coach motivation, and study strategies. The best designs give teachers direct controls to override pacing and to inject local curriculum priorities. Real-time adaptivity versus longer-term curriculum alignment. Adaptive tutors balance immediate responsiveness with curriculum coherence coherence. A short-term fix, drill a problem type, must feed back to the broader plan, unit objectives, assessments. Integration with standards and scope sequence planners ensures the tutor's local adaptivity serves the long-term learning map, privacy, data security, and model governance. These tutors track rich interaction data, step-level problem attempts, time on step, hint usage, and sometimes voice or written explanations. Responsible programs anonymize data, restrict access, and provide opt-out paths. Schools must have clear policies on how data supports learning, not surveillance. Model governance involves versioning models, auditing for bias, and providing explanations for pedagogical decisions. In short, adaptive virtual tutors use micro-skill models, probabilistic belief states, spaced retrieval, interleaving, and scaffolding/fading to fine-tune pace and practice for each learner, enabling more efficient, durable learning while amplifying teacher impact. Assessment automation, classroom and self-learning uses, and creator workflows for tutorial videos. Automated assessment is more than grading. It's diagnostic, formative, and timely. Virtual tutors automate assessments at multiple grain sizes. Micro-level diagnostics, step-level checks that identify specific misconceptions. Formative checks, short quizzes that inform next-day instruction. And summative readiness signals, probability a learner will meet the unit goal. The technology blends automated scoring for objective items, stepwise evaluation, evaluate the process, not just the answer, and AI-powered rubricing, scoring explanations and constructed responses with calibrated models. Stepwise evaluation powers meaningful feedback. Instead of marking a final numeric score, the tutor analyzes the student's solution path, where they hesitated, which sub-steps were missing, which hints they ignored. Automated essay and explanation scoring is improving. Natural language processing models can assess coherence, use of evidence, and reasoning structure for many student writing tasks, producing a rubric-aligned score and highlighting evidence gaps. Human spot checking and calibration remain necessary, especially for high-stakes tasks, but the scale of automated feedback frees teachers to focus on higher-order writing instruction. Practical classroom examples that scale. Flipped classroom. Creator videos deliver concept overviews. The tutor assigns mastery-oriented practice. Class time becomes interactive problem-solving. Bootcamp prep. Use tutor diagnostics to form micro-cohorts by skill. Creators record short targeted explainers for each cohort. Summer bridge programs. Tutors maintain daily practice. Creators make motivational short clips tied to weekly skill targets. Ethical and equity considerations for creators and schools. Ensure examples reflect diverse contexts. Avoid culturally narrow metaphors. Provide transcripts and language supports. Be transparent about data use. Accessibility features, captions, alt text, simplified transcripts should be standard. The near-term promise and the guardrails. Virtual tutors can amplify learning at scale, personalize practice, and free teachers for high-impact work. But the promise comes with responsibilities: robust privacy, fairness auditing, human oversight, and curriculum alignment. When designed and deployed thoughtfully, these systems become powerful classroom companions, not replacements, that help every learner find the right next step toward mastery. If you're passionate about AI, automation, and the future of smart learning, make sure you hit subscribe and turn on notifications. We break down complex tools into simple, actionable insights every week so you can stay ahead, stay sharp, and stay empowered. Welcome to the next chapter of learning.